Yes, ma'am.
Okay, fine. So today's topic is COCOMO model. Okay, COCOMO means constructive cost estimation model, okay? And it is basically a heuristic technique. Okay, it is a heuristic estimation technique. So basically, COCOMO or constructive cost estimation model was proposed by Boehm in 1981. So basically, Boehm postulated that any software development project can be classified into any one of the any one of the three categories based on the development complexity, like organic, semi-detached, and embedded. So see here, it is actually saying that it can divide software product into three categories. So this is important, students. As of now, whatever you have learned, that apart from the life cycle models, the next important approach is COCOMO, because in exam you might be given COCOMO model, explain COCOMO model. If you are giving offline exam, they may ask you that explain COCOMO model, explain the organic COCOMO model. In this way, they can ask you. You need to write it down. And otherwise, they can ask you some other, if you are giving offline exams, then in offline exam, you may be asked some other questions. Okay. Like small, they will be giving you some small portions of COCOMO, like what will be the full form of COCOMO. So in that case, you need to write constructive cost estimation model and many more things. What is organic COCOMO, then semi-detached. I will explain everything. So see here, basically in order to classify a product into identical categories, Bohem requires us, Bohem requires uh, considered not only the characteristics of the product but also of the development team and development environment. So basically, we can say that the three product cases correspond to application, utility, and system programs, respectively. Normally, data processing programs are considered to be application programs. So you know that there are three types of programs or software, that is application, then your system software, and another one is utility software. So can you tell me what is the difference between application software and system software, students? I have already explained this in the first class. Difference between application software and system software. Students, are you there? I'm asking you some questions. So, data processing programs are considered to be application programs. Compilers, linkers are utility programs, we know, and operating systems and real-time system programs are system programs. The system programs interact directly with the hardware and typically involve meeting, timing, constraints, and concurrent processing. So, there is another one named Brooks. Okay, so Brooks in 1975 had stated that the utility programs are roughly three times as difficult to write as application programs, and system programs are roughly three times as difficult as utility programs. Thus, according to Brooks, the relative levels of product development complexity for the three categories, that is application, utility, and system programs of products, are 1:3:9 ratio. Okay. So Bohem defines of organic, semi-detached, and embedded products like embedded systems are elaborated as we see here. First one is organic. So what is organic? We can consider a development project to be of organic type if the project deals with developing a well understood application. Okay? and the size of the development team is reasonably small and the team members are experienced in developing similar types of projects. Okay. Next comes semi-detached. What is semi-detached? A development project can be considered to be of semi-detached type if the development team consists of a mixture of experienced and inexperienced staff. So team members may have limited experience on related systems but may be unfamiliar with some aspects of the system in development. The next one is embedded. So a development project is considered to be of embedded type if the software being developed is strongly coupled to complex hardware or if the strong regulations on the operational procedures exist. So, Bohem, in addition to considering the characteristics of the product being developed, considers that characteristics of the team members in deciding the category of the development project. Thus, a simple data processing program may be classified as semi-detached if the team members are inexperienced in the development of similar products. So for the three product categories, basically Bohem provides different sets of expressions to provide the effort and development time from the size estimations given in KLOC. KLOC. Okay. Just a second. हाँ बोल अच्छा
Hello, hello.
Hello, students, am I audible?
Yes, ma'am.
Okay. So basically, see here. Basically, COCOMO model is having three categories. Okay, COCOMO model is having three categories. One is organic. Okay, another one is semi-detached, and the other one is embedded. Okay, embedded. So what is organic? So basically organic, it actually in organic COCOMO model, it is involving well understood application programs that are small in size. Sorry, well understood application programs. So well understood application programs are there. Small size development teams are there, and experienced team members are also there. Okay? So these three things are there. That is, one is well understood applications, then small size development team and experienced team. So that means whenever you are having experienced team members, even if the size of the development team is small, then also you can do it perfectly. So that's why it is called COCOMO model. Next, sorry, organic COCOMO model. Next is semi-detached. Okay, so in semi-detached, it is actually mixtures of experienced and inexperienced staff. Okay? Semi-detached means in COCOMO we are having experienced staff members, whereas in semi-detached we are having both experienced and inexperienced staff members. Okay, and the another one is embedded. Embedded is actually, it involves in the software development is strongly coupled to complex hardware or not. That is system program like OS, real-time OS system programs are there. So it is actually dealing dealing with the software is whether it is strongly coupled or not. So this is the COCOMO. Now there is another one. So now see here, for each of the three categories. Okay, so for see here, from the size estimation, Bohem provides equations to provide project duration in months and effort in program months. So Bohem obtained these equations, examined historical data collected from a large number of actual projects. Here, cost estimation is done through three stages, that is basic COCOMO. We are learning now basic COCOMO. We will learn intermediate COCOMO, and after that we will learn COCOMO in this basic COCOMO. This is the, remember students, all of you pay attention. This is the most important thing in COCOMO. That is, you need to calculate the effort and time of development. Okay, how you will calculate the effort? See here, KLOC. In the last class we have learned LOC. LOC is what? LOC means, what is LOC, students? Lines of code. So KLOC means kilo lines of code. Okay, so the simple data processing program may be classified as semi-detached if the team members are inexperienced in the development of similar products. So we all know this. For the three product categories, Bohem provides different sets of expressions to predict the effort and development time from the size estimation given in kilo lines of code. Okay, so 1% is 1% month is the effort an individual can typically put in a month. Okay, so this effort estimate takes into account the productivity losses that may occur due to loss of time, such as we can have holidays, then weekly offs, coffee breaks, etc. So this will be subtracted. So the total effort estimation is expressed in units of percent months. Okay? So the unit is percent month. So percent month is considered to be an appropriate unit for measuring effort because developers are typically assigned to a project for a certain number of months. The percent month unit indicates the work done by one person working on a project on 1 month, it should be carefully noted that an effort estimation of 100% months does not imply that 100% should work for 1 month. Neither nor does it imply that one person should be employed for 100 months. So the effort estimation simply denotes the area under the person month curve. So see here. So the three development estimation. These are the so to remember these two formulas, that is effort equals to A1 KLOC to the power. This is to the power A2, okay? Not into A2. Just see this. Effort equals to effort is equals to A1, A1, then K L O C. Okay, that is kilo lines of code to the power A2. To the power A2. Okay, this is effort, and then next one is time of development, T day. Okay, T day, what time of development? See here, it is given T day, that is time of development. That is, it is the estimated time to develop the software in months. So we will be writing it like P1 to effort deferred. Okay, this is person month. This is because effort we will be for effort we will be needing persons. So that's why person month it is person month and time of development is in months. So before calculating time of development, you need to calculate the effort, and after calculating the effort, you can put the formula into it, and you can calculate the time of development in that. Okay. So in this way, you can see here. Now, next, see this slide. Okay. Observe this slide carefully. So basically, we know that the basic COCOMO model gives an estimation or approximate estimation of the project parameters, and the basic COCOMO estimation model we know effort and is based on the expressions like effort and time of development. And we know that KLOC is the estimated size of the software product expressed in kilo lines of code. Okay. Now, according to Bohem, okay, you know Bohem is the founder of COCOMO. So, according to Bohem, every line of source code should be calculated as one LOC, irrespective of the actual number of instructions on that line. Thus, if a single instruction spans several lines, it is considered to be NLOC. Okay, that is number of lines into LOC. So it will be like NLO. Okay, NLOC. So see here, where N is the number of lines. So the values A1, A2, B1, B2. See here, this and B1, B2 for different categories of products is given by Bohem in 1981. He has given, and he has derived the expressions by examining historical data collected from a large number of actual projects. Okay. Effort estimation. Okay. Effort estimation, development, effort estimation. So for the three classes of software products, the formulas for estimating the effort based on the code size are given. See here, organic, that is effort equal to 2.4 KLOC to the power 1.05. Semi-detached, that is effort equals to 3.0 into KLOC to the power, this is to the power, okay, 1.12. So you need to remember this, okay? For organic, for semi-detached, and for embedded, the effort is like this. We know A1, okay? So A1 KLOC to the power A2. We know that is the formula. So here A1 is what? 0.4, then KLOC, then A2, A to the power A2. A2 value is 1.05. Okay. Similarly, here semi-detached, it is A1 is 3.0, then KLOC to the power A2, that is 1.12. Then effort 3.6, KLOC to the power 1.20. In this way, it is given. Development time estimation. Time estimation, see, we know that for organic, semi-detached, and embedded, three types of estimation time is there. So that's why, see, the time estimation was formula like first. It was B1 effort to the power B. So here, in case of organic, B1 is 2.5 effort to the power C, which is 0.3, okay? And in months. Next, for semi-detached, time of development is B1, that is 2.5 effort to the power D, that is 0.5 months. And for embedded, the time of development is B1, that is 2.5 effort to the power D, that is 0.2 months. So you need to remember this three, that is 6 formulas. Effort estimation for organic, semi-detached, and time estimation for organic, semi-detached, and embedded. So here, see, there is a curve, okay? So basically, we can gain some insight into the basic COCOMO model if we plot the estimated characteristics for different software sizes. So see here, this curve shows a plot of estimated effort versus product size. So see here the effort, and in the y-axis it is effort, and in the x-axis it is the size, okay? So here we can say that we can observe that the effort is somewhat linear. See, it is linearly increasing. So somewhat super linear, that is slope of the curve is greater than equal to 1. Okay. So if the size of the software product, so this is because the exponent in the effort expression is more than 1. So thus the effort required to develop a product increases rapidly with project size. So here the increase in effort with the size is not as bad as that portrayed. Okay, so the reason for this is that COCOMO assumes that projects are carefully designed and developed by using software engineering principles. So that's why we are using these concepts in software. So basically the development, this one is the development time versus the product size. Okay. Development time versus the product size. So in the x-axis it is the size, and in the y-axis it is the development time. So we know that development size and versus product size is in KLOC. So from this figure we can see that the development time is sublinear. So it is sublinear. So see here it is increasing in this way. So that's why it is sublinear function of the size of the product. So when the size of the product increases 2 times, the time of development of the time to develop the product does not double but rises moderately. So it may appear surprising that the duration curve does not increase super linearly. The apparent anomaly can be explained by the fact that COCOMO assumes that a project is carried out not by a single person but by a team of developers. So it is important to note that the effort and duration estimations obtained using the COCOMO model imply that if you try to complete the project in a time shorter than the estimated duration, then the cost will increase drastically. Okay, so that's why then there is almost no decrease in the estimated cost value. So that's why we can consider that the computed effort and duration values to indicate the model is actually the effort and duration values. Is actually the values for doing the work in the shortest time without increasing manpower cost. Okay. This is actually the basic focus. So development does not increase linearly with product size. So for larger products, more parallel activities can be identified, and we know that an optimum size teams is one in which developers do not have to waiting for work, but at the same time employs as many developers as possible. So that is why the duration given by COCOMO is called the nominal duration or as the optimal duration. So it is called optimal duration if the project is attempted to be completed in a shorter time, then the effort required would be rapidly rise. So see here, for a larger product, more parallel activities can be identified and can be carried out simultaneously by a number of engineers. Actually, development team is roughly the same for all the categories of products. And for example, a 60 kilo lines of code program can be developed in appropriately 18 months, regardless of whether it is organic, semi-detached, or embedded type. So there is more scope for parallel activities for system and application programs than utility. Here, this is an example given. So basically, see this example where the size of an organic software product has been estimated to be 32,000 lines of source code. So they have given. So here 32,000 lines. That is, you need to calculate in kilo lines of code. So that's why we are taking. See here, effort we know. What is the formula of effort? As I have said, it is like. This is given already, okay? So it is given that it is organic software. So we know that in case of organic cocoa, the last slide, as I said, okay? In the last slide, I have said that the calculation of effort for organic cocoa model is 2.4 KLOC, okay? KLOC the power 1.05. This is the formula. Person. This is the formula. Now see here, 2.4 KLOC here. We have given in the question, it is given 32,000 lines of code. Now if you want to make it in kilo lines of code, we will be dividing it by 1,000. So that's why we are getting 32. Okay. So see here, 32 to the power 1.05. So in this way, you can calculate. So see here, but you will be getting some values like it is to the power. It is not included. 91%. Okay. So it will be equals to 90. If you do the calculation, you will get to take a calculator. You will see that it is 91% month. It is getting. You are getting. Okay. Now next is time of development. So you need to calculate the time of development for them. And we know to calculate the time of development, we need effort, because in the time of development we are including the formula with effort. So that's why. See here, we have first, we need to, even if it is not given, if you are given in the question to find the time of development, then also you will be needing effort. So that's why first you need to calculate the effort for organic COCOMO model, and then you need to calculate the time of development for organic COCOMO model. So time of development is what? We know that formula is 2.5, okay, into effort to the power 0.38, okay, 0.38. This is the time of development. Now we have got the effort as 91, so we will put the value that is 2.5, okay, 2.5, 91 to the power 0.38, okay. This is the value. So That's why if you calculate it, you will get 14% more. Like for 14 months. Time of development unit is months. So 14 months. So in this way you can. The next topic is intermediate COCOMO. So I'm not going to explain intermediate COCOMO today. We will be explaining intermediate COCOMO in the next class. But as of now, we have completed COCOMO. Do you have any doubts, students, regarding COCOMO? Any doubt? Students, please respond. Any doubt regarding COCOMO? Respond. So no one is responding. So I'm assuming that all of you have understood that what is COCOMO. Okay. So here from the we have seen that from the effort estimation, the project cost can be obtained by multiplying the required effort by the manpower cost per month. So in this project completion computation, project cost computation is the assumption that the entire project cost is incurred on account of the manpower cost alone. So in addition to manpower cost, a project would incur costs due to hardware and software required for the project and the company overheads for administration of its space. So another point should be carefully remembered while doing COCOMO is that from the effort estimation for a project expressed in a programmer months and the nominal development time, the novices would determine the staffing level by a simple division. However, we are going to examine the staffing problem in more detail. So that's why this is actually a simple division approach to obtain the staff size is highly improper or not. Okay, so this is all about COCOMO. In the next class, I will be starting intermediate COCOMO. But before that, you need to know about COCOMO because COCOMO is kind of important topic for your exam. Even if you are giving online or offline exams, COCOMO is important. Any doubts, students? Anyone? Is it clear? Response, students. Students. So you know that you need to submit your assignment. You have all, I think all of you have submitted your assignment because you were supposed to submit the assignment yesterday, within yesterday. So all of you have submitted, I guess. If anyone is left out, that student is instructed to submit the assignment in the respective folder. Don't forget to submit the assignment. Everyone should submit, otherwise I will not give marks to those students. Okay. Thank you, students, for attending this class. Now you can.